Hello guys, in today's video I want to show you how to implement insertion sort, and I will also explain it. We will implement it in Python 3 and use the sort colors problem in lead code in order to test it. So the insertion sort is very simple algorithm that goes that is implemented with two loops, one outer and one inner. The inner loop will start from the index 0 plus 1 from the array, so it will start here from 1, and the outer loop will start from index 0 from here, so like that. Let's also enumerate other indexes, so like that. And on each iteration of the outer loop we will have a variable, let's call it key, and on each iteration of the outer loop it will be the inf index of that array. So in this example it will be 2, and so it will point here, and we will compare the key with the variables that is pointed by the inner loop. So we will compare if 2 is less than 5, then we will perform the swap. But actually we can just place the 5 here, and our inner loop will go to 0 to the end, but at the end it will always be decremented by 1, so it will actually, on the last iteration it will be here, but it won't go inside the inner loop. In the code you will see what I'm talking about. So, and at the end we will place our key by j plus 1, so the inner loop index plus 1. So here will be our 2. So, and on the second iteration our outer loop and our key will be here, so key will be here 9, and our inner loop will go from index of the outer -1, so 1. I think you get it. And but for the others, for other who doesn't, I will continue to implement it. So here it is 9. 9 is not less than 5, and also 9 is not less than 2. So we will do nothing. So actually in code we will swap the 9 with 9. We could have an if, but it doesn't matter. So it isn't costly, but if we implement it with if, it will have the same cost. So here now our key will be equal to 1. Let's use violet color like here, and we will compare. 1 is less than 9, so 9 will be placed here, then 5 is less than 1, so we will also place 5 here. So, and the way why we are not swapping in place, like we could put 1 here and then compare it like that, because it will be costlier. So now you can just pretend that this slot is empty. So, and now we will compare 2 is less than 1, so 2 will be placed here, and at the end now it is here, so we will place the key here, so like that. And I'm sorry, I was a little distracted because I can only upload less than 15 minutes in YouTube because my account isn't verified, so I'm probably gonna cut it, but if not, it doesn't really matter, so like that. So on key we will have our 5, like that, and this case is pretty interesting because it's the first time when we want to reach the outer, the last, and we will actually do the swap, so it will be 5. So 5 is less than 9, so here will be placed our 9, and the inner pointer will be here, and we will implement it that way that it won't go further and won't swap 5 with 5, so we will swap this one, so we won't swap this, and 5, the constraint of the inner loop will be that it will go till the end, or till the key is less than in value by the our inner loop. So in this case we will just put here our 5 that initially was here, so here will be our 5, and if not, we could potentially swap it like that, and then this inner loop would be here, and we will swap this 5 with actually not z5. Z5 is here, we will just swap it, but in that way we would mix the first 5 would go before the second 5. It doesn't matter because it is just numbers, but it could be some objects with numbers, so it's better like that. So on next iteration we will have our outer loop at 6, and our key will be 6, so 6. Let's use the violet color, and this one will be here, so we will compare. 9 is we could compare 9 is greater than 6, but we will actually compare 6 is less than 9, so 9 will go here, and the pointer will go that iteration here, so 6 is not greater than 5, so here we will place our 6, and like that our array will be sorted. So, and now let's actually implement it. For that we will have our outer loop, so it will go from 1 till the end, so length nums, and on each iteration, the first iteration we will have our key that will be equals to nums I, and also we will have our j that will be equal to I minus 1. So after that we will have our while loop, that's why we have our j, so it will continue when j is greater or equal 1, and nums j is less than key, and if it is so, then nums j plus 1 will be equal to value before it. So it is essentially our swap, and we will do after that j -1 because we are going backwards, and after that we will do nums j +1, so j +1 will be equal to our key, and we did it. So at the end, for I when nums for I in range, of course. So I was saying, so when it is at the last, okay, we have implemented algorithm for sorting from the greatest to lowest, because we are doing nums j is less than key. No, of course we need to compare if the key is less than nums j. So essentially when nums j, when value before it is actually greater, so we will swap it. So let's test it again, and yes, like that it is good green. So yes, so that's all for that sorting algorithm. Very simple one. The only confusing part is this one, because we are not doing the swap, we are just putting the value to the right and not putting the key there. But we can skip it, because we need essentially to put the key in the right place, or the j+1 just in at the end, when it reached the last index of the array, or when actually nums j is not greater than key. We will also do the second the value after that. We will populate it with key, so like that. So thank you for watching, and subscribe and leave comments. Bye.